Okay, let's start a new chapter, that is chapter number 4 from chemistry portion, carbon and its compounds, right? So in this chapter we are going to discuss in detail regarding the carbon and its compound, and you are known regarding the compounds, right? So what are compounds? That means when elements are combined together in a definite ratio, it forms what? They form compound, right? Now carbon and its compound, it means what? Here we will be discussing regarding carbon, formation of bond of carbon with any other elements, right? Now you know that this carbon, it is a widely used element, right from the medicine, from plant, animal. In most of the cases, or in most of the time, the substances what is very much essential for us, or the substances which normally use, are what? Made up of carbon. That means carbon is found in these substances also. Now you know that millions of compounds of carbons are available. So we must know that what is the source of this carbon, how we have been getting this huge number of carbon compounds. Now basically there are two sources of carbon, that is from the atmosphere and from the earth crust. From the atmosphere, it is you know that carbon dioxide is present in the atmosphere, and whose composition is nearly 0.03%, right? So in this carbon dioxide means what? CO2, right? So in this CO2 we have carbon, so this is a source of carbon. Again, from the earth crust, in the form of minerals, any other elements, its amount is nearly equal to what? 0.02%. So in the regarding the percentage of its existence, it's very less, but still it has a wide application, or numerous number of compounds of carbons are available. So we'll discuss in detail in this chapter, how it is possible, and why it is forming such a huge number of compounds, besides its natural existence is very low. In the earth crust, in the form of coal, carbon and petroleum, they are found. So while going to discuss regarding the carbon compounds, first we will come to know regarding the bonding in carbon. Okay, so how carbon forms bond. So the first topic is bonding in carbon, the covalent bond. So you know that covalent bond and ionic bond. Ionic bond in the experiment number 3, you have got when metal transfer electrons to the non-metals, then the resulting bond becomes ionic bond, right? Now in case of covalent bond, what happens here? The sharing of electrons occurs. That means what? In case of carbon shares electron with other elements to form bond, and as a result the compound which is formed is known as covalent compound 2. Now why carbon forms a covalent bond, right? Why not the ionic bond, though ionic bond is comparatively much more stronger than the covalent bond. Now here you see what is the reason behind it. So you know that if ionic bond is to be formed, that means what? Ion must be there. So if carbon forms ion, there is how many types of ions are there? Obviously two types of ions are there, cation and anion. Now if carbon forms cation, then it must form C4 positive cation. By releasing its 4 electron, it will acquire the configuration of helium. So if cation is possible, then it is in the form of C4 positive, and if anion is possible, then it will be in the form of C4 negative. Now at first you see regarding the carbon, it's a distribution of electrons in the different shells of carbon. Here you see we have electronic configuration as 2 4. So distribution of electron will be 2, then 1 2 3 4, that is 2 shells are involved. First shell is known as K shell and the second shell is known as L shell, right? This is the distribution of electron. Next you see if carbon forms cation, it will be in the form C4 positive. So if C4 positive is to be formed, that means 4 electrons are to be removed from the outermost shell of this carbon atom, and if these 4 electrons are removed, then it will be in this format, right? And one more condition is that C4 negative anion. Now if 4 electrons, extra electrons are to be added, then the outermost shell will acquire 8 electron, which is also somewhere stable form. So if C4 positive ion is to be formed, then as 4 electrons are to be removed from the outermost shell, so a huge amount of extra energy is required to remove 4 electrons from the outermost shell, and which is practically not feasible. That's why C4 positive form is not possible. Now regarding this C4 negative, so if C4 negative ion is to be formed, then you know that 4 extra electrons are to be added in the outermost shell of carbon. So this addition of 4 extra electron to the outermost shell of electron is not possible, because nucleus is unable to hold 4 extra electron, as we are adding only electron, not the proton. And you know that in an atom, number of electrons and protons are same, so and protons are present in the nucleus, so nucleus must support or must hold the extra electron. So 4 extra electrons which we are supposed to add to the outermost shell of carbon is not being accepted by the nucleus of carbon. That's why C4 negative condition is also not possible. So as these two ionic form, C4 positive and C4 negative, is not possible, that's why carbon will move towards the next option, that is covalent bond, that is sharing of electrons to form any compound. So that is the reason behind the formation of covalent bond. Now this covalent bond is formed by the other elements also, not only by the carbon. Suppose you see, if we consider the formation of H2 molecule, hydrogen, so its atomic number 1, that is 1 electron is present. Now if H2 molecule is to be formed, then you know that for this hydrogen, suppose if it is to get what stability, or if it is to fulfill its outermost shell, it needs one more electron. So if H2 molecule is to be formed, here 2 hydrogens are involved, so both need 1. So for this purpose, what they will do, you see here, this hydrogen, suppose this is the electron of this hydrogen, and for this hydrogen this is the electron, so they will share their electron here mutually. That means mutually they will acquire 2 in its circumference, or in under the boundary of this hydrogen 2 electron, here under the boundary of this hydrogen again 2. So they shared these 2 electron mutually, so that they can get mutually stability. As one pair of electrons are shared, so the bond between these 2 hydrogen will be single bond. So single bond indicates one pair electron is shared, that is 2 electrons are shared. The same thing is applicable in case of oxygen molecule also. So if you see the electronic configuration of oxygen, then it is as 2,6. So you know that if I write this electron, outermost electron, it is 2, 4, 6, right? So from here it is clear that oxygen needs 2 more electron to fulfill its octet, or to fulfill its outermost shell. So for this purpose, whenever oxygen is going to form O2 molecule, then they will share how many electron? 2 electron, because they need 2 electron to get their outermost shell fulfilled. So here you see, for this oxygen, as outermost shell of oxygen contains 6 electron, 2, 4, 6 for this oxygen. For this oxygen, 2, 4, 6. So 2 from the right side oxygen, 2 from the left side oxygen will be shared, and as a result both will get stable. Now you see, under the boundary of this oxygen, if you count the number of electron, it will be come out as 8. Again, under the boundary within the region of oxygen of this side, if you count 2, 4, 6, 8, that means by sharing 2 electrons, both will fulfill their octet, or both will try to fulfill their outermost shell. As the number of electrons, or the pair of electrons shared between these 2 oxygen is what? How many? 4 electron. 4 electrons means 2 pair, so the bond between these 2 oxygen will be double bond. So single bond and double bond is on the basis of how many electrons are shared between the 2 atoms. Now let us consider the example of one carbon compound. In case of carbon compound, you see here a structure of what? Electron dot structure for methane. Okay, methane means what? It is as CH4. Methane means what? CH4. Okay. Now in this CH4, if I write the electronic configuration of carbon 2, 4, okay, hydrogen 1, it's done, right? Now for this carbon will share how many electrons? 4 electrons, because carbon if it is to fulfill its octet, or if it is to form bond, then this 4 electron is to be shared. For hydrogen 1. So what is done here, you see, carbon, just to distinguish the electrons of carbon and hydrogen, I have shown the electrons differently. That is, electrons of hydrogen are being marked as point, and for carbon it is star mark. Now you see, for carbon 1, 2, 3, 4 at the very initial stage. For hydrogen, this is the electron, this is the electron, this is the electron. That is, 4 hydrogens surround this carbon. Now what will happen? This hydrogen, it's 1 electron, along with the carbon's 1 electron, it will form this structure. That is, within the boundary or region of hydrogen, 2 electron. For this side hydrogen, this dot electron is of hydrogen and this star is of carbon. So with this star of carbon, it will form, there is electron, not the star, it will form what? That is 2. For this hydrogen, the same procedure. For this hydrogen, again same procedure. And what carbon will do now? Now carbon, already it has 4 electron in its outermost shell, and from the 4 hydrogen it will take 1 1. So within the boundary of carbon, now how many it will come? 2, 4, 6, 8. So carbon also will get some stability. As the bond between this carbon and hydrogen, how it is, you see, single bond, right? Single bond, single bond, single bond. So why single bond? Because the number of electrons shared between carbon and hydrogen is how many pair? 1 pair. So 1 pair means 1 bond, single bond, 1 pair single bond, 1 pair single bond, 1 pair single bond. So as electrons are being shared, so the bond would be covalent bond, and this is the formation of CH4 molecule. Now regarding the allotropes of carbon, okay, and allotropes means what? Naturally existing different forms of an element. This is the allotropes. So carbon has 3 allotropes: diamond, graphite, and Buckminster fullerene. Now in the case of diamond, you know that if you look at the structure of diamond, so it is what? Rigid 3-dimensional structure, where 1 carbon atom is bonded with 4 other. You see, suppose I have considered this carbon 1, 2, 3, 4. So the structure of diamond is rigid 3D structure, where 1 carbon atom is bonded with 3 other carbon atoms. In case of structure of graphite, you see here it is an hexagonal arrangement, where 1 carbon atom is bonded with 3 other carbon atoms. You see, 1, 2, 3. One more properties of diamond is it is the hardest substance known, and again regarding the graphite, it is a very good conductor of electricity. And in case of this, you see Buckminster fullerene here, it is a football-like structure, where 1 carbon atom is bonded with 3 other atoms of carbon. So this is about what? Allotropes of carbon. Now let us come to the next topic, that is versatile nature of carbon. Versatile nature means what? To show a different kinds of nature or different ability, a multitudinous properties shown by the carbon. Now why carbon shows this extra nature or something extra credibility? This is due to its 2 reasons, and why a lot of number of carbon compounds are found. This is on the basis of its 2 properties, that is catenation and tetravalency. These 2 properties are shown by carbon. So catenation, it is the property due to which similar kind of atoms are bonded together to form a long chain. Now if similar kind of atoms are bonded together to form a long chain, and that property is known as catenation. In case of carbon, you see these things are found. Here you see, this is the carbon. Same kinds of carbon atom can be bonded in this manner. Again you see we can branch the carbon chain also. Again you see we can give double bond also, we can give triple bond also. That means what? Carbon can form straight chain, branch chain, and ring also. Again it can form a double bond, triple bond. So obviously you see as these structures are possible, that's why it will form a huge number of compounds, because you see the name of this compound will be one compound, this will be different compound, it will be different compound, right? And a huge number of carbon compounds can be linked together to form a long chain of to form a huge molecule, and that property is known as catenation, which is shown by carbon. Regarding the tetravalency means what? Valency 4. Obviously you know that if I write the electronic configuration of carbon, it is as 2 4, right? That means 4 electrons are available in the outermost shell. So due to the availability of this 4 electron, what will happen? Carbon can share these 4 electrons with 4 other monovalent atom. Monovalent means what? Which have the single valency. Suppose you see we have seen carbon can form bond with 4 hydrogen, right? And this is possible due to the available 4 electron. If 4 electrons were not available, then this compound might not be formed and it's not possible to form. In the same way, you know that regarding the formation of carbon dioxide, in case of carbon dioxide also we have seen that in case of carbon dioxide we have seen that CO2, that means 2 oxygens are bonding with carbon. And how it is possible? Because carbon has available 4 electron and 2 oxygen, and then it's what? 1 oxygen needs 2, so 2 oxygen needs 4. So carbon has available 4 electron, so 2 oxygen can share 2 electron with the carbon to get what? Mutual stability. As a result, carbon dioxide is also possible. That means what? Due to this available 4 extra electron, these things are possible, and due to the catenation it can form a huge molecule, that is numerous number of carbon compounds can be linked together to form a long chain or branch or ring, and which results different types of compounds. Okay, for today up to this. Thank you.